All right, guys. Your central question for today is how do we find the composition of functions? And guys, all a composition is when you take one function and plug it into another. What you're doing is just like music. When you're making a composition of music, you're taking all those different parts and combining them into one. So you got your brass section, your woodwind section, and you're combining it into one composition. That's the same idea behind a mathematical function composition. Now, my disclaimer, I'm only going to go over two types of composition, Fogg and Goff. But in reality, guys, when you take college algebra, there are more compositions than that because you can actually plug a function into itself or vice versa. So, but for this, we're just going to worry about basic composition, Fogg and Goff. All right, for this, let's just look at an example right quick that you don't have to write down, but let's just look at it together. So let's say that I have two functions. Sometimes it's necessary to perform the basic operations on our functions, just like you have the basic operations on numbers, adding, subtracting, multiplying, and dividing. It says, for example, let's pretend that the amount of money that John earns at work can be defined by the following function. P of x is equal to 1450x plus 5. So in other words, that function says that John makes about $14.50 an hour, and then he gets $5 as his base pay. Let's also pretend that the amount of money Allison, his wife, earns at work can be defined by the following function. M of x is equal to 16.45x plus 3. Well, that basically says that Allison makes about $16.45 an hour, so she makes more per hour than her husband, but she only gets a base pay of $3 as opposed to her husband gets a base pay of $5. Well, each one of those represents a unique function to each of those people. Well, what if I wanted to determine the function that shows the total amount that this couple brings home? Well, if I wanted to find the total, then all that means is I would do what with those two functions? Add them, right? So sometimes it's necessary to add functions together. In fact, sometimes it's necessary to perform operations. Take a second and write this problem down. And it's two parts. It says f of x is equal to 3x minus 4, and g of x is equal to 4x plus 5. And this is a very simple, straightforward question that says, find the sum, difference, product, and quotient for the following two functions. And so what I want to show you is that just like you can add, subtract, multiply, and divide numbers, you can do the same thing with polynomial functions. So what I mean by that is, let's say that I wanted you to find the sum. So let's say I wanted you to find f of x plus g of x. As elementary as this sounds, all you're really going to do is take those two functions and add them together. So add 3x squared minus 4 and 4x plus 5. And then, of course, just do your algebra. Make sure any like terms that can combine together, and there are. I see a negative 4 plus 5, so that's going to give me a positive 1. And so that would be my new function, which would be the sum of those two functions. So, I mean, just like you can add two numbers together, you can literally add two functions together and get a new answer. What you got?
3x plus b squared.
Yep, thank you. 3x squared. I saw you when you made your little head turn, so I knew something I'd messed up somewhere. So 3x squared plus 4x plus 1. I'm going to change color so you can see it a little bit better, too. Now, when we're talking about the difference, let's say I wanted you to do f of x minus g of x. So just like you can subtract two numbers, you can subtract two functions also. But here's the most common mistake. Just remember, when you're subtracting a polynomial, you always got to remember to change your what? Yeah. So guys, make sure when you subtract that second function, that positive 4x becomes a negative 4x, that positive 5 becomes a negative 5. But then you treat it the same way. See if there's any like terms to combine together, and there are, negative 4 and negative 5. And so that gives me my new function in blue, 3x squared minus 4x minus 9. And so that's how you find the difference. So just like you can subtract two numbers, you can subtract two functions. All right. Product, just like you can multiply two numbers, you can also multiply two functions. So let's say I wanted you to find f of x times g of x. So you would literally have 3x squared minus 4 times 4x plus 5. And then just like any other algebra problem, you just FOIL this out. You would get 12x cubed and then plus 15x squared minus 16x minus 20. And I don't see any like terms to combine together, and so that would be my new function, which would be the product. and so that would be the product of those two functions. So just like you can multiply two numbers, you can multiply two functions. The last one, quotient. Just like you can divide two numbers, you can also divide two functions. And so like if I wanted you to tell me what f of x divided by g of x is, that would literally be the f function in the numerator and the g function in the denominator. And I'm actually going to leave it just like that. I'm going to go ahead and tell you that there's nothing else I can do to that, but we're actually going to spend a separate day just talking about these types of functions. This is what we call in math a rational function, but we're not going to learn about those today. We're going to save that for a different day. But that would be my quotient, literally just this divided by that. And this is a good teachable moment right here. If no math teacher has ever told you this, guys, 5/7, a lot of people don't like fractions. Guys, that division symbol, all that means in math is divided by. So 5/7 is the same thing as 5 divided by 7. If nobody's ever told you that, that's a good teachable moment right there. That fraction symbol, all that means is division. So that's it. All right, so that's pretty straightforward. Now, keep in mind, guys, that's technically not your essential question, but this is one thing that you'd have to cover in college algebra. In fact, most college algebra classes, they start right here with asking you to add, subtract, multiply, and divide functions. But what our essential question is how do we do something called function composition? So let's talk about that for a second. So take a look at this example I've got down. So functions can also be combined by using something that we call composition. In composition, what you do is you take one function and you plug it into another function, or vice versa. You can take one function and plug it into the other. So that's what function composition is. Think of it like this. You can think of composition in terms of manufacturing a product. For example, the first thing you do is you have cotton, and it's made into cloth. But then you take that cloth and you make it into a shirt. So in other words, the cotton is composed into cloth, and then the cloth is composed into shirt. But it's a two-way operation. So that's the same thing that we're going to do with math. Now, the two basic forms of composition are what we call FOG. And the reason why it's called FOG, guys, is because it looks like the letters F-O-G. But in reality, guys, the symbol is F with a little O right there, and then G. But that's the symbol that stands for FOG. And what that means is F of g of x. In other words, the g of x is inside the f function. The other composition is GOF. GOF, and it's called GOF because it looks like the letters G-O-F. But in reality, guys, the symbol is G with a little o and then F. And what that symbol stands for is G of f of x. So, guys, these two things are not the same. The FOG, the G function, is inside the F. But with GOF, the F is inside the G. So that's the two differences between FOG and GOF. Now, again, my disclaimer, guys, is when you take college algebra, you could also do f of x, or you could do g of x. So, guys, there's more composition than just what we're going to be doing for this class. But it's all done the same way. One function is plugged inside of another. Now, here's my hint for you to help you do these. Start on the inside and work your way out. So, in other words, if you have FOG, start with g of x. If you have GOF, start with f of x. Start on the inside and work your way out. If you can do that, these are going to be a breeze for you. All right, let's take a look at an actual example. Let's say that I give you these two functions. F of x is equal to 2x plus 5, and g of x is equal to 3 plus x. It says to find FOG and to find GOF. Now, guys, on the test, I'm not going to ask you to do both. I'm only going to ask you to do one. But I want to show you how these two questions, they're not going to have the same answer. So it does matter. So let's do FOG first. Now, if you remember, FOG stands for f of g of x, which means I'm going to start with the g function, and guess where I'm going to plug it into? The f. So watch what happens. Y'all see the g function right here. You see I circled it. Let's plug that into the f function. So you see wherever there's an x, we're going to plug in that 3 plus x. So here's what you have. 2, and then inside of that x, you'd have 3 plus x, and then plus 5 on the outside. So you literally, wherever you see an x, you just plug in that other function. So you're literally composing something new. Then just do your algebra. Distribute, so you're going to get 6 plus 2x plus 5. Combine your like terms, so I get 2x plus 11. And that's it, guys. That's your answer. That's how you do function composition. Now, let's compare that, so versus GOF. If I ask you to find GOF, you'd have to do g of f of x. And this is different, right? So this time you're going to take the f function and you're going to plug that sucker into g. So circle the f function, 2x plus 5, and you're literally going to plug that into the g function. And so what you're going to have is 3 plus, and you see what that x is, plug in 2x plus 5. And so I plug in 2x plus 5, and then I just combine my like terms, and then you get 2x plus 8. And that would be the answer for that one. All right, let's look at another example. Let's take it up a notch. So this time it says fog and golf. And then to split this up, so ladies, if you want to do fog, and fellas, if you want to do golf, and then I'm going to do both of them so you can check yourself. But let's say that you want to do fog and golf for these two functions. Now, usually what happens, guys, is that there's going to be an easy one and there's going to be one that's a little bit more involved. Don't really know which one it is right now. So let's talk about fog versus golf. So remember, fog is f of g of x. So I'm going to do g into the f function. So I'm going to plug g into f. So for fog, all right, ladies, so I'm going to take this function and plug it into the f. And I think y'all are going to get the easy one because all I do is 2 parentheses x squared minus 2x minus 3. And ladies, all y'all have got to do is distribute. So 2x squared minus 4x minus 3. And that is it. Y'all are done. So fog was good. Golf, fellas, that means g of f of x. So you mean you got to plug the f of x into g. So I'm going to take this and plug it. Here's what makes it difficult, into here, but also into there. So what I'd have is 2x minus 3 squared minus 2 times 2x minus 3. So this is definitely the one that's more involved. Now, here's a common mistake, guys. You can't just assume that 2x minus 3 squared, that is not 4x squared plus 9. You can't just multiply them. Remember, that stands for FOIL. You're going to have to write that twice. You're going to have to FOIL this out. So 2x minus 3 squared literally means 2x minus 3 times 2x minus 3. So when I FOIL this out, I'm going to get 4x squared minus 6x minus 6x plus 9. And you notice these don't cross out. That gives me 4x squared minus 12x plus 9. And then distribute here, you get negative 4x plus 6. And you do have like terms to combine together, negative 12 minus 4, so negative 16x, 9 plus 5, that gives me 15. And so, fellas, that would be your answer for that one. All right, guys, the last example that I want to do with you is this one. All right, so for this last one, let's say that I wanted you to find fog first, so f of g of x. All that means is f of g of x. So start with the g of x, plug that in. So you will have to plug it in 2 places. So you'll have 2 and then 5x minus 6 squared minus 3 times 5x minus 6 plus 8. Again, the most important thing here, guys, is do not distribute. FOIL this first. So I'm literally going to have 5x minus 6 times 5x minus 6. Let me do my arithmetic and watch my numbers. I should get 25x squared minus 30x plus 36, and I'm going to go ahead and combine my like terms right now, and so I'm going to get negative 60x plus 36. But now that I'm done with that, what I need to remember to go back and distribute that too. So what I'm going to do is I'm going to rewrite everything over again. That way I can see it for what I have. Distribute, I'm going to get 50x squared minus 120x plus 72. Then I'm going to distribute this negative 5 and get, negative 3, and get negative 15x plus 18 plus 8. And then just combine your like terms. So 50x squared, negative 120, and negative 15. So that's going to give me negative 135x. 72 plus 8 plus 18. That should give me a positive 98. How did y'all do?
I just added my x's.
Good. Okay. Yeah. Biggest thing is watch your signs. Yeah. Now, this is the thing. Even look, after you do that one, this one's going to be so much of a breeze because golf is just g of f of x. So you're literally just going to take this and plug it into that one little spot right there. So you'll have 5 times 2x squared minus 3x plus 8. Don't forget the minus 6 at the end though. Distribute, you get 10x squared minus 15x plus 40, and then don't forget the minus 6, and so you end up getting 10x squared minus 15x plus 34. But that's it.